Hello, today we're going to talk about the binomial theorem and the binomial expansion. Now, as you know, the binomial is a polynomial that has two terms, and when we talk about expansion, it means that we can raise the binomial to a power of n, any power of n, such as power of 0, power of 1, 2, 3, 4, 5, and so on, up to any exponent that we want. Now, as we raised a binomial to an exponent, we notice a few things. First of all, in each expansion, there are n plus 1 terms. So power of 0 will have one term, power of 1 will have two terms, power of 2 will have three terms, and so on. We notice that the powers of x decrease. So they go from power of 2, power of 1, power of 0, and if we look at a bigger expansion, power of 5, 4, 3, 2, 1, 0. And on the other hand, y increases from power of 0 to powers of 1, 2, 3, 4, 5, all the way to n. We also notice that there is a coefficient in front of each term, and the coefficients start easily with 1. We see 1 here, and then we go up in coefficients that increase and then decrease in a symmetric pattern. So the coefficients of a binomial expansions, or binomial coefficients, are represented in the way that we see here. So n choose r, this is read as n choose r, or in this other notation that we will not use that much anyways. The binomial theorem tells us that in the expansion of x plus y to the power of n, each term is made of a coefficient, n choose r, x to the power of n minus r, and y to the power of r. Now, n is the power of the binomial expansion, and r is the position of each term. So it will be position 0, 1, 2, 3, 4. Each coefficient can be calculated using this formula. N choose r equals the n factorial over n minus r factorial multiplied r factorial. Let's see what that means with an example. If I want to find the coefficient in position 2 of an expansion of a binomial to the power of 8, I can do the following. 8 factorial over 8 minus 2 factorial times 2 factorial. And 8 factorial is 8 times 7 times 6 times 5 and so on. 8 minus 2 factorial, or 6 factorial, is 6 times 5 times 4 times 3 times 2 times 1 times 2 times 1, which can be easily simplified as, let's see what I can get rid of. All the 6's, 5, 4, 3, 2, 1, and I'm left with 8 times 7 multiplied 2 times 1, which is 4 times 7 equals 28. Now, we will do the same for these. You can stop the video and try it yourself if you want, or look at my solutions in a second. And this is what I get. I can easily simplify the 4 factorial with the 4 factorial. 4 times 2 is 8. 6 divided by 3 is 2. And I'm left with 7 times 2 times 5, which is 7 times 5 equals 70. This would be the third one. And this is the last one. Please remember that 0 factorial is always equal to 1. Now, a faster way to find the coefficients of a binomial expansion is to use Pascal's triangle. Look at what we see here and see if you can figure out what the pattern is and how you can expand it. You may have seen this before, but otherwise, see if you can find the next 5 rows. Okay, you may have noticed that in this triangle, each term is, each number is the sum of the two numbers in the row above. So 3 is the sum of 1 plus 2. 5 is the sum of 4 plus 1. And you can continue. You notice a few things. You notice that the first diagonal is all made of ones. And actually, this is not the first diagonal. This is called the diagonal number 0. The first diagonal would be this one, where all the numbers correspond to the number of the row. The rows are numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the diagonals as well are numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, Pascal's triangle is very convenient when you have to do a big expansion because it gives you the coefficient of an expansion for each term. So, for example, if I want to see the power of 5, see here, this one, the coefficients for the 6 terms will be 1, 5, 10, 10, 5, 1. And I can go on. If I want to see, expansion to the power of 10, you will see the coefficients will be 1, then 10, then 45, and so on and so forth. So using Pascal's triangle, see if we can answer the question to the first problem and see if we can find the same values that we found before, that we calculated before, if we can do it by using Pascal's triangle. So in this case here, we want to find the coefficient of the term in second position on the 8th row. So second position, this will be the 8th row, this one here, and the second position will be, let's see, number 0, number 1, number 2. And there you go. So this coefficient will be 28. And the next one will be same row, position 4. Position 4 will be 70. And we have it here. Position 6 will be, again, 28. Please note that the second and the 6th number are the same because the triangle is symmetrical. So we have, once again, 28. And finally, position 0. Position 0 will be the first term here. Every term in position 0 will always have coefficient 1. And these are the same numbers that we saw before when we expanded by hand. There you go. 28, 70, 28, and 1. And now we can try to do a full expansion of a binomial. So x plus y to the power of 5. So I can start by expanding the first term, the first term of the binomial, x. X will be x to the power of 5, then 4, then 3, then 2, then 1, and then 0. We don't see it here. Then we can expand the y. Y will have increasing powers. So the first term will have y to the power of 0, so we don't see it. Y to the power of 1, y to the power of 2, then power of 3, power of 4, power of 5. And then I can put in the coefficients in the 5th row of Pascal's triangle. The coefficients will be 1, 5, 10, 10, 5, and 1. Now, please notice that these are all terms of my expansion, so I will have to add them. So I will have x to the 5th plus 5x to the 4th y plus 10x to the 3rd y squared plus 10x squared y cubed plus 5xy to the 5th plus y to the 5th. And that is the full expansion of a binomial to the power of 5. In the next example, I have to pay attention to two things. Number one, one of the terms is a numerical term. It's a number 5 and not a letter. And the second thing is that we have a negative sign. So let's see what happens here. I can start with the coefficients according to the first row of Pascal's triangle. Then I write my first term with decreasing powers, 4, 3, 2, 1, and 0. And then I write my second term, 5, with increasing powers, 0, 1, 2, 3, 4, but I make sure that I include the negative sign. I now calculate these powers, so negative 5 to the power of 0 is 1, minus 5 power 1 is minus 5, minus 5 squared is positive 25, minus 5 power of 3 is negative 125, and minus 5 power of 4 is positive 625. I put everything together and I find 1, 2, 3, 4, 5 terms. The powers is 4, so I expect to find 5 terms with the coefficients that are alternatively positive and then negative, positive, negative, positive. In the next example, the first term is has both a numerical and a literal part, so I have to make sure that I pay attention to that. You can pause and try it yourself and then check my expansion. Make sure when you raise to a power, you include everything, positive and negative signs, you include the numbers, you include the letters, everything. Expand. And finally, put everything together and you should have this answer. And now you try this one. Go ahead. And this is the answer. Please make sure you don't skip steps as you go through this, because it's very easy to make mistakes, especially when we have a negative number or when we have a numerical coefficient for one of the terms. In the next example, we're not asked to find the whole expansion, but just one specific term, or better, the coefficient of one specific term. Now, you remember that each term is made of a coefficient, x to the power of n minus r, and y to the power of r. So, in this case, we see that the second term is negative 2b, and it's raised to the power of 5. So, 5 will be my r in this case. The whole expansion is raised to the power of 11, so my n will be 11. So, this will be 11 minus 5. And this will be 11 minus 5, so power of 6, we see it here. And this one will be 11 choose 6. I calculate 11 choose 6, which will give me 462. So we'll have 462, a to the power of 6, minus 2 to the 5th is negative 32. I'm sorry, this is wrong. It's not power of 2, obviously, but it's power of 5. And then I put everything together, and I find that 462 multiplied negative 32 will give me the coefficient of this term, which is going to be negative 14,784. And finally, let's look at a tricky one where we're asked to find the sixth term. Now, the sixth term, as you remember, is the one in position 5. So r equals 5. Remember, the positions are not numbered 1, 2, 3, 4, 5, but they're numbered 0, 1, 2, 3, 4, 5, 6. So the sixth term will be the one in position 5. According to my calculations or Pascal's triangle, the coefficient will be 56. Term 3a will have to be raised to the power of 8 minus 5. And the second term, 2b, will have to be raised to the power of 5. And everything. And I find my final answer. This will be my sixth term. Now try the few practices, and I will show you the answers in a second. This is the first one, and this is the answer. Next problem. A pretty big coefficient for this one. And in the last one, you're asked to find the full expansion of the binomial raised to the power of 4. And this is the last one. Pay attention to the signs, to the coefficients, and then you're ready to try a few by yourselves. Good luck.